we are on section 1.7 today, and it is linear inequalities and absolute value inequalities. And I'll go ahead and make this statement one more time, that Unit 1 exam is next Thursday. And that is September 18th, right?
Yes.
Yes, September 18th. And I think I had said y'all's was going to be on the 16th, but I'm going to make it the 18th. We're just going to do it the 18th. So you have time to do your 1-7 homework. 1-7 will be due Monday night, okay, before the Tuesday that you come in. Yes, ma'am.
So again, tested on whole of chapter 1?
Yes. It will cover do we start in 1-4? Yeah, with complex numbers. 1-4, 1-5, 1-6, and 1-7 is what it will cover. There is a Unit 1 review posted. It is optional. I will leave it open until test date, so when you look at it right now, it may say the 16th and not the 18th, but I'll leave it open to the test. If not for the entire semester, I may leave it open the entire semester. And I'm kind of just writing that there for my benefit, so when I go back and look at the notes, I can click around. Okay? So, Unit 1 exam will be next Thursday. I try to give you a review at least a week in advance so you can work on it throughout the days. Like I said, there are 1-7 questions on there, which right now, if you looked at, you probably couldn't do, but we're going to cover 1-7 today. Tuesday, we will cover 2.1 from Unit 2, but it will not be on the test, on this test. It'll be on the next one. Okay? All right, so if we're going to talk about 1-7 today, linear inequalities and absolute value inequalities. Yes, ma'am.
Is it test the calculator?
You can use the little TI-30XS. You can't use a graphing calculator. You can use any scientific calculator. It just can't be a graphing calculator. This is the one we say, yes, fine. That's fine also. As long as it's scientific and not graphing, then you're good. Okay, pretty much, guys, they want you to be able to graph equations and functions and solve without the use of a calculator is what it is. They're fine in college algebra if you multiply, divide, add, subtract on a calculator. That's not the goal of college algebra, okay? Okay, we need to talk about some interval notation to start with. When we talk about an open interval notation, okay, we use parentheses. And we're going to cover this a little more in-depthly. We're going to have a long list in a minute. And then we use set builder notation also, not a X. Okay. Now, what this says, this is an open interval. It goes from the values A to B. It doesn't include those values because it's a set of parentheses. And then this little chunk out here in the curly braces is called set builder notation. And it's read X such that A is less than X is less than B. So it's talking about all the values in between A and B. Okay? Graphically, it's going to look like this. And we're just talking graphically on a number line. So if this is A and this is B, and it'll have parentheses there, and we're talking about all the values in between A and B. So this set of parentheses is not used as plotting a point. Some of you, when you see the set of parentheses, you automatically think, okay, we're going to plot a point. Okay, this is talking about the interval, and by interval we mean the interval of values that are occurring. Okay, but that's open interval notation. Closed interval notation we use brackets, okay? So we'll have something like a bracket A to B. Set builder says X such that A is less than or equal to X is less than or equal to B. And I'll make you a little note in a minute how to read those brackets. I know you hear me saying it, but that doesn't help you when you go away for like 4 or 5 hours. And then you go, what does she mean with those curlies and that straight line in there? Generally, even if you're an international student, you have seen mathematically, you've seen the curly braces, you've seen the straight line. That is pretty much universal in any type of mathematics where you're accustomed to set builder notation. That's why it's a lot easier for international students. They excel mathematically. Well, one, generally in a different country, y'all do harder mathematics than we do. It's not as watered down as the United States. I'll need to chop that out of the video. So y'all do more difficult mathematics, but you use very strict notation in whichever country you came from, generally. Okay, and then if we're going to graph that, I might not cut that out. I mean, it's a true fact. Y'all come here and do high school math, and your international students will go, I did this in the 6th grade. This is grade 6 for me. And, you know, we're teaching it in the 10th grade. It's like, yeah, I know. Brackets denote closed interval notation, infinite interval notation. Is going to have your parentheses, and it's going to have an infinity in it. And the way this is read is X such that X is greater than A. Okay? And we can also use interval notation, infinite notation. Infinite interval notation. You'll see, and I'm sure you do, those emails popping up. I teach, I'm adjunct for Lee College down in Baytown, and they have a Unit 1 exam due this week. I have a lot of dual credit students in there, and they're sending me emails going, hey, my proctor, my monitor needs a passcode. But I'm just glad they're doing it today on Thursday instead of waiting until 3:15 on Friday. Okay. So we can also combine that bracket in infinite interval notation, and we're going to have something like X such that X is less than or equal to B. Okay. Oh, I didn't draw our little graph a while ago. Y'all didn't tell me. And we're doing X is greater than A? Yeah. So we would have our parentheses. There's my A. And this means we use all the numbers to the right of A. Y'all have done this before. You graphed inequalities on a number line before. Most of the time, your Algebra 1 teacher probably went, okay, which way does the arrow point? That's the way you shade, is probably what she said. And if we're using that closed bracket on there, so it's actually equal to B, we're going to have, and this is less than, So I'm gonna put my B right here. I'm gonna use a bracket. I'm gonna say that's B, and I'm gonna shade to the left. So here's the gist of that. You may not have used, you used parentheses and brackets. You didn't use parentheses and brackets probably on your actual number line. You used open circle, closed circle. You remember open circle, closed circle? If it's equal to, then it is a closed circle. If it's equal to, it is a bracket, okay? That hard bracket, pretty much, guys, the way I think of it in my head is that bracket is a hard closed area, okay? So it's an equal to. The parentheses is softer. We're kind of getting there, but we don't actually hit it. That's not included, okay? So let's look at this in very specific format. We've got, I'm going to put interval notation. We're going to make some columns. It's kind of like a table. We're going to write the interval notation. And then we're going to have set builder. We're going to write it in set builder notation. And then we're going to graph it. And that is a cursive G. So I'm going to show you, what I'm doing is I'm writing it in an interval notation, and then I'm going to show you how you can see it in the two other forms. Okay? So if I have something in interval notation and we have maybe AB, parentheses, A, comma, B, close parentheses. Okay? In set builder, this means we would write it as X such that straight line up and down means such that. Okay? Some old dead math guys long ago, and you know they were dudes, they had to be, because it was like long ago in Plato time. Some old dead math dudes said we don't want to scratch all that out on some kind of piece of rock, or, you know, squeeze some berries and put it on some leather paper thing. And so they developed notations, so they didn't have to write out words like such that. They were looking for shorthand pretty much. And so that little straight up and down bar in the curly brackets that denotes set builder notation says X such that. Now, we're talking about the values that lie between A and B. So, but not including A and B because it's a set of parentheses, not a bracket. So we're going to say A is less than X is less than B. Okay? And you had that one up here. That was the example that we gave on that open interval where we're using open interval. Okay? Our graph, we drew the graph up there earlier. Here's A, here's B. And like I said earlier in high school, you would have graphed this with the open circles and you would have shaded the part in between. This is the way you would have seen it in probably high school. In Texas, we used open circles, closed circles, okay? We can have it, of course, two closed brackets, two closed circles, and that means two equal to's. So I've got X such that A is less than or equal to X is less than or equal to B. Okay. I'm not going to draw the circles this time because this textbook does not talk about open closed circles. They use the brackets and parentheses. And so you're talking about all the numbers in between A and B, including A and B. You'll notice in that set builder it says equal to, okay? Now, you can have it half open, half closed, half open. So I'm going to use, let's say closed on A, open on B. Okay, so that means it's going to be equal to on A, and just, we're not going to have an equal to on B. So I've got X such that A is less than or equal to X is less than B. That's what it says. Okay, so that means at A, I'm going to have a bracket. At B, I'm going to have a parentheses. That would have been a closed circle, open circle. Okay, I can have it the other way around. I can have an open interval at A, so it doesn't actually equal A. And then I can have it closed at B, so it's equaling B. And that's going to give me X such that A is less than X is less than or equal to B. Okay, so I'm going to use open on A, closed on B. Okay, we've got to include our, now we've got to include the infinities, those infinite intervals. Okay, so we can have an open and then an infinite. Guys, when you have the infinite, you never use a bracket with infinity. And here's why. Do we ever get to infinity? We're always approaching it. We keep going and going and going and going, but we never get there. Okay, so it always has a parentheses. It's always open. And since we start at A and we're going to a positive infinity, this is X such that X is greater than A. Okay, but it's not equal to. Okay, so we've got parentheses at A, so it doesn't actually equal the number. And it is going to a positive infinity. Now we can have that with a closed bracket on A. So closed at A, open on infinity. It's a closed infinite interval, okay? So X such that X is greater than or equal to A. And so I have A, this time with a bracket, that means it actually equals it. And I'm going to a positive infinity. Okay, now you can come from a negative infinity, okay? So we're going to use B and talk about the negative infinity. Well, if I'm coming from a negative infinity, I can come up to B, but it not be closed. It's open. And this is going to be X such that X is less than B. Because, guys, we're talking about, we're coming from negative infinity, so it's this direction for y'all, all the way up to B. And we stop at B. So that means all the numbers less than B, they're negative numbers, right? Eventually. You eventually get to the negative numbers down there. So this is going to give me, here's B. And we're going to shade to the left. And I will tell you the old trick that your algebra teacher would give you and tell you which direction to shade. As long as X is on the left, you start with the left, the arrow tells you the correct direction, and it's not a compound inequality. These at the top, these first four at the top, those are what we call compound inequalities. Compound because there's two inequalities. Remember, math people are very literal. Think about what a compound fracture is. Okay, you break in a couple of bones, it's sticking out the skin. It's compounded, right? It comes out. It's torn through multiple things. Okay, compound inequality, we got two inequalities in there. I forgot my curlies. Okay, how about that we can do the negative infinity with a closed bracket on B. So that's X such that X is less than, I got ahead of myself. X is less than or equal to B. Okay. And I've got B. I'm going to put my bracket there. And I go to the left. And we can also have two infinities, negative infinity to positive infinity. Of course, we're going to have parentheses on both of those because we never get there. And sometimes in set builder notation, we'll write x such that x is in this funny looking R. Okay, so that E, that funny E with the, it's like a C, it's like a curvy E, curvy capital E. That means it's in the set of real numbers. The R stands for the set of real numbers. Now, you may not see it written that technically. You will also see it like X, such that X, they'll actually write it out for you, is a real number. And we're going to put that under there because that's pretty much what that means. Sometimes they'll use the funny looking R. It has kind of two backs, and it's usually italicized a little bit. It slants a little. I can't really make it italicized looking. And guys, if we're talking about it's a real number, we're talking about everything, it's just the whole number line, right? There's no brackets, there's no parentheses. Okay, so here's the gist. If we have some brackets, we're going to have equal to. We'll have a less than or greater than equal to. It's got an equal to on it, okay, in the set builder. If it's some parentheses, it's less than or greater than. Doesn't actually equal it, okay? Just approaches the number, it doesn't actually equal it. And when I write something like x such that x is less than a, this line right here is read such that. Okay? X such that x is less than a. And I'll even write all that. X such that x is less than a. All right, so let's make some sense out of that because y'all were just very nice, compliant students that wrote down what I told you to write down. Okay? So example 1 says express each interval in set builder notation and graph. Okay, so set builder, if you go back and look at your chart and look at your columns that we drew, set builder is the curly braces, right? Set builder means curly braces. Set builder is generally not your friend. You don't like it. That's because we typically teach it much more easily with parentheses and brackets first, and it's like we don't make you use big people math. And set builder notation is big people math. You'll see it if you do set theory. You'll see it when you take discrete math. You'll see it when you take Diffie-Q, like when you're doing mechanical engineering stuff. You keep seeing curly brackets. It's big people math. Okay, that's for Alex. Are you doing engineering too?
I'm doing mechanical.
Yeah, you'll keep seeing it. You'll keep seeing it in more math classes. Yeah, Alex is too. I just knew he was because we had that conversation because he's ECHS. And I was like, you're probably taking more math classes after this one, but you are too. So, set builder is the curly braces, okay? So A says we want -2 to 5 with a parentheses, okay? Okay, express each interval in set builder notation and graph. It's easier if we graph first, right? Yeah, because I just draw my number line right here. And guys, if you want to put 0 on there, you can. You don't have to, but you can, so that you note that's where 0 is, okay? Kind of have a reference point. And I mean, you don't even have to count out nicely. Your homework probably will have it counted out nicely because it's going to be accurate, but you will find that eventually they don't. And you don't, okay? But this is what we're graphing on. We've got a number line. It's just standard old number line. It's not graph it on a coordinate plane. This is before that, before you're even graphing it. This is probably, I don't know when you guys start graphing on a just basic number line. Maybe 5th grade, 6th grade, I don't even remember these days. So I just go -2, and I make a bracket at -2 because it's actually equal to, I've got my bracket, and then at 5, I make my parentheses, and then I shade in between. That's the graph. You're talking about all the numbers from -2 up to 5. Okay? And you got to think about that for when you do set builder. Set builder always starts off, curly bracket, X such that. Okay? Now, since this doesn't have an infinity in it, this has numbers, that means we're going to have a compound inequality. So X is in the middle. You put your inequality, your less thans in there. So now you just got to figure out if it's going to stay less than, or if it's going to stay, or if it's going to turn into less than equal to. Okay? Put your numbers, -2 to 5. Right? That's what it tells me, -2 to 5. Now, is it equal to -2 or is it just greater than -2? It's equal to. Put your line. 5, is it closed bracket or parentheses? It's parentheses. So I leave it just with the less than. Okay? What this says is that X is bigger than -2, but he's less than 5. He's -2 or bigger, but he's got to be less than 5. That's what your graph says. That's what your interval notation says, okay? They've just made you list it all 3 ways, but you're done. Okay, let's do B. B says I'm going from 1 to 3.5. We've got bracket, 1, comma, 3.5, close bracket. Okay, I'm going to graph it first because that is typically easier. Here's 0, 1, 2, 3, and there's 4. I'm actually going to, I'll just list through 4. And then here's, I'm going to put 1. Okay? So, open or closed at 1? Closed because it's a bracket. So, I'm going to draw a bracket. And then at 3.5. It's closed also. Okay. I'm coloring in between. Gonna start, you're done with your graph now. I'm gonna start with my set builder. I start off X such that, put my X in the middle. Put my inequalities. Are they equals to? Yes, they're both equals to because they're brackets. Write your numbers, 1, 3.5. Ta-da. We're done. Okay? It's not a hard concept. It's just you have to understand the notation. That's all it is. You have to understand what the notation means. I'm going to do -infinity to -1. Okay? Here's 0. -1, I'm going to draw a +1, try to confuse you. Okay? What happens at -1? Open or closed? Open, because parentheses mean open. And I gave it away, didn't I? Because I drew the parentheses the way it goes. Gave it away. Parentheses there, and we shade to the left because we're coming from negative infinity. We want all the numbers below -1. Okay? Shade to the left. We're going to write our x such that, now this time, we can't do our doubles. We can't do our doubles because we've got an infinity on there, okay? So you know you have a 1, and you know you got an x. So ask yourself, is x less than -1? Is it the numbers less than -1, or are they greater than -1? What did we graph? Less than, good. So you just write that x is less than -1. And it's less than because it's open. Okay? Okay, we wrote the other one. So, just a little side note. Open means parentheses. Closed are my brackets. And remember, that's a less than, greater than. This is a less than, equal to, greater than, equal to. Okay? Just a little side note there. All right. Let's talk about intersections and unions of intervals. Oh, that's nice. Okay? Okay, so we need to define some symbols here. If I have an upside down U, it's like an upside down capital U, or it's like a parabola that opens down. Most of you remember what a parabola is. That's when we graph it, we have x squared, blah, blah, blah. It's quadratic. Parabolas usually open up if A is positive. If the leading coefficient is negative, it opens down. Okay, it's like an upside down parabola. That upside down parabola, though, for you guys right now, means intersection. Okay? If it's an intersection, it's an overlap. It's in both. Okay? If it's a union, guess what? I use kind of a U. Looks like a capital U, but doesn't have stick on it. So it's not really a capital U. It's a union symbol. But it's easy to remember because union starts with U. So union equals both together. It means both together. Okay? And pretty much the rest of the lecture is examples. And we go through example 10. Example 2. But you guys got to know how to do it, right? We want to use graphs to find each set. So I have 1, 3 in brackets intersecting 2, 6. Okay, so I'm going to use some different colors here so that we know what we're doing. We're going to draw our graph. And the first thing I'm going to do is I'm going to draw the 2 parts that we want. And then I'll shade the answer that we're talking about. Okay, so I've got 1, 3, and 2, 6. I'm going to start, since we're using positive numbers here, I'm going to start my 0 over here. It's fine. Guys, you can start your number line where you want to, okay, based on the values that you have. You won't always have real close numbers to 0. So 1, 2, 3, 4, 5, 6. Okay. I could have spread that out a little bit. Let me spread that out a little bit. 1, 2, 3, 4, 5, 6. So that y'all can see better. You don't have to spread yours out. I need to spread mine out so you can see. Okay, so I'm going to graph the first one. Okay, 1, 3. So I got a bracket at 1. I've got a bracket at 3. And I'm going to highlight those blue. Okay, that's me coloring it in right there. And you'll see why I'm using colors in a minute. Okay. The next one says we're doing 2, 6, right? Okay. So I've got a parentheses at 2. And then I've got a parentheses at 6. And I'm going to highlight those yellow. Okay? Now, it says it's an intersection. And what did we say intersection meant? It means overlap. It's in both of the parts that we graphed. So your answer is where the graphing overlaps, because this is an intersection. It has the upside down U, so it's in both. So your answer is the green part, right? So if you had to graph it just by itself, the answer by itself, 0, 1, 2, 3, your answer would be right here, 2 to 3. Let's make it, nope. This is your answer, guys. Here, because it's an intersection. It says use graphs to find each set. That's your set. This is your answer right here. Okay? Because it's an intersection. You want to know where both of those graphs happen. They overlap from 2 to 3, right? The first one goes 1 to 3, and the next one goes 2 to 6. So what did they have in common? 2 to 3. Okay? Kind of, sort of. Let's do a B. B says, I wrote the exact same thing down. Oh, no, I didn't. I'm like, why did I write the same thing down? 1, 3 united with 2, 6. Okay, notice, I even tricked myself. This time it's a union. Okay? So we have a union. And union means both together. Both. All. Okay? If you have a union, like people are getting married, you're uniting two families together pretty much, right? It's a union. So whatever we graph, we want all of it. Like from the lowest to the highest all together. So we have the same graph that we had here. 0, I think I made it bigger this time. 1, 2, 3, 4, 5, 6. And I've got my 1, 3, okay? And that's this chunk. And then I have my 2, 6. And that's all of this together. And we want the union, so we want everything that's shaded. So our answer will be, who's my lowest value I have marked on there? 1? So I have a bracket at 1. And then I'm going all the way to 6. And I didn't leave myself enough room. I can get it. Okay, and that 6 has a parentheses, and I'll go ahead, I'll do it in green, since that's how we did our answer a while ago. Okay? Goes from 1 to 6, because you're uniting the parts together. That a little better? All right, let's look at example 3. Example 3 says solve and graph the solution set on a number line. And you guys are going to be pretty good at this because 55. This is like what you always kind of do. 2 minus 3x is less than or equal to 5. And this one actually throws in that little rule that we have to remember. And I don't care how long ago it's been since you took Algebra 1, you still remember. If you're solving an inequality and you multiply or divide by a negative, what do you have to do? Flip the inequality. Yeah, flip the inequality. Yeah. So, goal when we solve is to get x by itself, just like it always is. So I'm going to subtract 2 from both sides, just like you've been doing. I got negative 3x is less than or equal to 3. Now I'm going to divide by negative 3. So we're going to write ourselves a little note out here. When solving an inequality, if we multiply or divide by negative, flip the inequality. Okay? Okay, so I'm dividing by that negative 3. So this is going to be x is greater than or equal to negative 1. Correct? There's first part of our answer we solved. Okay? Now we need to graph it. So I'm going to draw my number line. And I've got x is greater than negative 1. So I'm going to put 0 right here. I'm going to make this negative 1. Okay? Parentheses or bracket. Bracket, because it's closed. And am I going to shade to the left or to the right? Right. And this is where your teacher's voice of, the inequality tells you which direction to shade. That is correct, as long as x is on the left. And for you guys, most of your purposes in high school, you always got that letter on the left. Variable to the left, variable to the left, variable to the left, to the extent that sometimes you think you're wrong if it lives on the right-hand side. You're not wrong. It can live on the right-hand side. Okay, that's your answer. We good? See, that's pretty easy. All right, let's look at example 4. Y'all got that? Can I move? It's your Friday, I know. Example 4. We have solve and graph the solution set. On a number line. Okay? I've got 3x plus 1 is greater than 7x minus 15. 3x plus 1 is greater than 7x minus 15. This is not a compound inequality. This is just a normal inequality. We just have to get the variable all on one side, right? Okay? I'm assuming you guys probably want to get that variable on the left. so that it tells you how to graph easier. So we're going to move the 1 to start with. So I'm going to subtract 1 from both sides. That's going to give me 3x is greater than 7x minus 16. Okay, I do it just like I would solve an equation. Okay, then I'm going to subtract 7x from both sides. That's going to give me negative 4x is greater than negative 16. Now I need to divide both sides by negative 4. What do I have to remember? Flip the sign because I divided by a negative. So x is now less than 4. Okay, first part of your answer. Now let's graph it. I'm at 4, so 0, 1, 2, 3, 4. Am I going to shade, open or closed?
Open.
And left or right?
Left.
Good. Open, shade to the left. Remember, when I say open, we use a parentheses. Okay? That's example 4. Example 5. We have, once again, solve and graph the solution set on a number line. Okay, so I have x minus 4 divided by 2 is greater than or equal to x minus 2 all over 3 plus 5 over 6. Okay, now your biggest issue here is getting rid of those fractions, right? That's what you don't like. Guys, the easiest way to get rid of the denominator is to multiply the whole thing by that denominator. Okay? Now, some of you can see, oh, well, the common denominator there is 6, and so I'm going to multiply the whole thing by 6, and that's going to get rid of them all at one time. But if you don't see that, you don't have to do it that way. We're going to do it by each one where we just get rid of each denominator, okay? So, who's the first denominator that I want to get rid of? 2, right? So, I'm going to take this, and I'm going to multiply the whole thing, both sides, by 2. And I'm going to say 2 over 1. Because, guys, isn't 2 really 2 over 1? Okay? So, what happens is, whatever denominator that you decide you want to get rid of and that you're multiplying by, that's what actually happens on that fraction, is you get rid of that denominator. Okay? So, since I'm multiplying by 2, and this first term of x minus 4 over 2, those 2's are going to cancel out, because what's 2 divided by 2? 1. So this just becomes x minus 4 is greater than or equal to, and we're going to keep it simple. I'm going to say, we're saying 2 times x minus 2 all over 3. That's all it does, because it's top times top. 2's in the top, x minus 2's in the top, right? All over 3. Plus, okay, 2 times 5 all over 6. I've literally just written what's happening, right? Didn't multiply anything out. Don't have to multiply anything out. Wait till the end to do all the multiplying, so you know where you messed up. Okay, what's the next denominator I'm gonna get rid of? 3. Multiply the whole thing times 3. Okay, well that's gonna be 3 times x minus 4 is greater than, well, 3 times 2. Oh, no. Do I have to write the 3 in the top this time?
No.
No, because that's the denominator I'm getting rid of, right? So they're going to cancel. So now I've got 2, x minus 2. Woohoo! Gotten rid of 2 of them. Plus 3 times 2 times 5. all over 6. Okay? Let's say that you don't see that 3 times 2 is 6 and that cancels out. Let's just say you don't. Okay? You're just laser focused on getting rid of those denominators. So who's the last one we need to get rid of? 6. Okay? So, now I've got 6 times 3 times x minus 4 is greater than or equal to 6 times 2 times x minus 2 plus, those 6's in the bottom fall out, right? So that's 3 times 2 times 5. Now it makes it bigger. The number's bigger, but you have now eliminated all your fractions, right? Okay. So this becomes 18 times x minus 4 is greater than or equal to 12 times x minus 2 plus, what, 30?
Yeah.
Okay. Now what we want to do is, you can go ahead and multiply that out. Go ahead and multiply it out. So you're going to distribute it. That's going to give me 18x minus 72. 18 times 4 is 72. 8 times 4 is 32. Carry 3. Yeah, 72 is greater than or equal to, distribute that 12. 12x minus 24. Does everybody see where I'm getting these?
Where did you get 17?
18 times 4.
Okay.
There you go. And then I've got 12 times x and 12 times negative 2. Then plus 30. Okay? Let's combine it a little more. 18x minus 72 is greater than or equal to 12x plus 6. Because negative 24 plus 30 is plus 6. Now I'm ready to start moving things from side to side. Subtract that 12 over. That's going to give me 6x minus 72 is greater than or equal to 6. I put 7x, sorry. 6x minus 72 is greater than or equal to 6. Add the 72. Six x is greater than or equal to what, 78? Divide both sides by 6. Do I have to flip my sign this time?
No.
Nope. I get x is greater than or equal to
13.
13. Good. Okay. There's your first part. And now you graph it. Here's 0. Somewhere down here is 13. Okay. See, that's you don't draw all those little marks out. And is it going to be open or closed?
Close.
And which direction?
Right.
Right. Closed with the bracket, then it goes to the right because it says x is greater than or equal to 13. The bracket takes care of the equal to. The arrow going to the right takes care of the greater than. Okay? Not bad. We ready? Y'all got it? I'm going to flip the page. Okay. Sample 6. Solve each inequality. We do not have to graph this time. All we're doing is solving. Okay? That's nice. We've got 3 parentheses x plus 1 is greater than 3x plus 2. Okay? This example shows some special cases. There's an A and a B, and it shows both special cases. Okay? So, you don't realize it's a special case till, oh, yeah, that's a 3. I'm sorry. Oh, I didn't pull the thing down this morning. That's my bad. I'm sorry. I didn't pull the screen down. You just start off like you normally would. You're going to distribute that 3. So that's going to give me 3x plus 3 is greater than 3x plus 2. Okay. You're going to switch sides over here, and I'm going to say 3x minus 3x. Bless you.
Thank you.
Okay. And that's going to give me 3 is greater than 2. And you're like, what happened to the x's? Where did they go? Okay, well, they can go away. It's all right. But you can't solve for x, right? Because there's no x left. So you got 3 is greater than 2. Is that true or false? It's true. Since it's true, that means you're going to write all reals. Or you can use your big R. They might use the big R, all reals. Because what this means is it doesn't matter what x value you pick. You can pick 1, you can pick 10, you can pick 30, you can pick -5. It doesn't matter, -100. Whatever x you plug in, you're going to get a true statement. Because there's 3x on both sides. You got 3x plus 3, you got 3x plus 2. 3x plus 3 is always going to be greater than 3x plus 2 because 3 is bigger than 2. Okay? So you can put any number in there and it will work. Okay? So you may get one where the x goes away and the statement is true. If that's the case, x goes away and the statement is true. That means it's all reals. Okay? They might also, if you had to graph it, guys, you're doing -infinity to infinity. You're graphing that. Okay? So it would just be a number line and you just shade the whole number line. Okay? So let's look at B. 6 says x plus 1 is less than or equal to x minus 1. Okay, so I'm going to subtract my x. Some of you can see how it's going to be, how it's going to happen again. Now I have 1 is less than or equal to -1. Is that true?
No.
No, this is false. So I'm going to write empty set. They might write out empty set. More than likely, what they're going to say is they're going to do a circle with a line through it. Or they're also going to say no solution. And what that means is it doesn't matter what x you pick. You never can make it true. Because what happens in the end is they're always saying right here that 1 is less than or equal to -1. You're adding the same thing to both sides with whatever x you pick. And 1 is never going to be less than -1. So there's no solution. There's no x you can pick that's going to make it work. Okay? All right, example 7. People start moving around way too early. I don't think people keep their kids till 9:55. Y'all are like, yeah, you math people do. Well, they do. They tell us to. They tell us, you don't let them out early. They'll find out. People find out. Keep them in there. Oh, I shouldn't have said that. I'm recording the lesson. I'm doing a screen recording so you can hear me talk, and I was going to post it. But now I have to go back and edit out things I shouldn't have said.
Including that?
Including that? Yes. Seriously. You could hear from my office my voice talking, and I'm chopping out stuff. And there's, pause. We're going to cut right there. Let's see how far it goes. Okay, delete that. From yesterday. Solve and graph the solution set on a number line. I have 1 is less than or equal to 2x plus 3 is less than 11. And so now we have compound inequalities. Okay? Okay, so, guys, the only thing different with the compound inequality is whatever, you got to get x in the middle. Okay, so let's say that, get x in the middle. Okay, and what you do to the middle, you got to do to all three sides. What you do to the middle, you must do to the remaining sides. Okay? It's just like we do when we solve equations. It's just like when you have multiple children at home. If you give one of them something and then you don't give the other one, you're going to hear about it. Why did she get this? Why did he get that? Yeah. It's the same thing. It's got to be fairly equal. You can't go into, well, you know, okay, I'm not going to do that because I'm recording. So I'm going to subtract 3. We want to get x in the middle. I'm going to subtract 3 from all 3 parts. Y'all know what I mean by all 3 parts? Can you see the 3 parts? Okay, because it's like there's a line that goes, remember a long time ago you had to draw the line? Yeah. Okay, so there's a line down each inequality. So that's negative 2 is less than or equal to 2x is less than, 8?
8.
Yeah. Now I need to get rid of the 2 in the middle, so I'm going to divide everything by 2. And that's going to give me negative 1 is less than or equal to x is less than 4. Okay, that looks nice. That's a good problem. That's your answer right there. And then they want you to graph it. Okay, so here's, we'll make this 0. Here's negative 1, and then I have 1, 2, 3, 4. Bracket or parentheses on the negative 1.
Bracket.
Good. And a bracket or parentheses on the 4.
Parentheses.
Good. And then where do I shade? In the middle. Guys, if it is a compound inequality like that, those numbers on the end set your boundaries. You're shading in the middle. Okay? Not bad on 7. The next part, I just kind of need to get... I need to get at least one of those examples done. It is over solving inequalities. With absolute value. Okay, solving inequalities with absolute value. So example 8 says solve and graph the solution set on a number line. Okay? And I have absolute value of x minus 2 is less than 5. Okay, so here's the deal. Here's the deal. And here's why we had, because you know with the absolute value, that could be a negative 5 in there, right? So we have to write that, and this is why we do compound inequalities before it, is you have to rewrite this as a compound inequality with that -5 on there. So you're looking at the values between -5 and 5, because all the values in between -5 and 5, when you take the absolute value of it, it turns less than 5. It produces a value, a positive number that's less than 5, right? But if you took negative values beyond -5, like -6, when you took the absolute value of that, what would happen? It would become positive, and then it's greater than 5. So that's the explanation behind the setup. We're going to write x minus 2 in the middle, and we write our less than 5. We write just what we have, but then we add on to the left-hand side the opposite value. Okay? The negative. It's got to fall in between that range. -5 to 5. Because everything in there becomes positive. Now we just add the 2. That's when it's less than. Okay, so we got -3 is less than x is less than 7. Okay? So what this says, what this is telling me is I can pick any x between -3 and 7, and it will be less than 5. It'll come out less than 5, is what it's saying. I plug it in there, plug it in that for that x and the absolute value, and it'll come out less than 5. Okay? So here's a 0, here's a -3, and I'm just going to put my 7 down here. On both of them, do I have open or closed? Open. And I'm going to shade in the middle because that x is in the middle. Okay. We can get example 9 in there real quick. And you don't really have to have 10. We can get 9. We're going to solve and graph again. And I will write 10 on the bottom before I post the notes so that you can see it, okay? I have -3, absolute value of 5x minus 2 plus 20 is greater than or equal to -19. Okay, your goal, you got to get the absolute value by itself. Just like yesterday when it was an equation, what did we do? The first thing we did was get absolute value by itself. So I'm going to subtract the 20. Okay, that's going to give me -3. Absolute value of 5x minus 2 is greater than or equal to -39. Okay, now I'm going to divide both sides by -3. What do I have to remember since it's an inequality?
Flip the sign.
Flip the sign, so I get the absolute value of 5x minus 2 is less than or equal to +13. Okay? Now you're ready to expand it. So I've got my -13 less than or equal to 5x minus 2 less than or equal to 13. You put the negative on the left. You add the negative, you add that less than equal to. Okay? Add 2, add 2, add 2. That's going to give me -11 is less than or equal to 5x is less than or equal to 15. Left-hand side doesn't look too great over there, but that's okay. Okay, divide both sides by 5. It's going to be right, though. When I divide by 5, that's going to give me -11 over 5 is less than or equal to x is less than or equal to 3. So what it's saying is that you can pick a value between negative 11 over 5, which is about negative 2 1/5, okay? And positive 3, and it will work in that equation. This is first part, and then, of course, you guys can graph that. Is it going to be open or closed? It's going to be closed and closed, correct? And so I get a closed on a negative 11 over 5, and then I got a positive 3 over here, and I shade in between. Okay. And like I said, number 10 is okay. Number 10, you need a rewrite on there. It shows you 18 is less than the absolute value of 6 minus 3x. Guys, if you get it where the absolute value is on the wrong side, remember how I told you? If you want to flip both sides, you can do that and not change, not do plus minus. That should be an X on there. Sorry, was rushing. 3x. So you can rewrite this with 6 minus 3x. You can put the 18, but you've got to make sure the inequality is going the right direction. What's the big end of the inequality open to? What am I opening to? The absolute value, right? Make sure, see how in here, the wide end is open towards the arrow points to the 18, right? The point points to the 18. When you rewrite it so that you can solve it, that arrow needs to point to the 18. Of course, that is going to throw you a problem on writing the inequality. But I'll post this. I'll post it worked out, and I'll make an extra little video where I'm working out example 10, okay? So that you know how to do it and you can view it, all right? Because it is a little tricky. They go different directions on the graph, okay? But I'll work it out and I'll post it on the notes in Canvas, okay? Okay, and if you have homework problems like that and you just couldn't get to it, couldn't do it, we'll talk about it on Tuesday, and I'll reopen the assignment if I need to, if there was something weird like that going on, okay? All right, guys, thank you.